Good day and welcome back for our fourth and final installment on tangent planes and approximations. We finished the previous video by mentioning the fact that you can find a worksheet covering these topics on Canvas. So hoping that you have spent some time going through the worksheet, working the problems. There's also solutions posted. A problem that we did not encounter in our previous three videos is number 4. Where we are asked to use differentials to estimate the amount of tin in a closed tin can with a diameter of 8 centimeters, a height of 12 centimeters, if the tin is 0.04 centimeters thick. So in terms of the dimensions we're given, we're told that the diameter is 8, so we could say the radius is 4, and the height would be 12 centimeters. Now in terms of how we approach this, we want to estimate the amount of tin in a closed tin can. That's how much tin is being used to make maybe this soup type of can. And we would estimate or measure this amount of tin in terms of a volume. So thinking in terms of cubic centimeters, how much volume would we estimate is in this tin can? And of course we could figure this out exactly, but that's not the point of the exercise. The point of the exercise is to do so using differentials, and as usual we should be very careful to follow the given instructions. So to get started, since we're talking about volumes, let's note that the volume of a cylinder is given by pi r squared h, where r is the radius and h is the height. So think the area of the base times how tall it is. And what we want to do is approximate, in a sense, the change in volume associated with the thickness of the can. So in our case, what we are going to do is estimate the true change in volume associated with the thickness. So that would be approximated by dV, and what we want to know is precisely what is dV when r is 4 centimeters, h is 12 centimeters, we have a small change in radius and a small change in height. And note the small change in the radius and height is specifically due to the thickness of the can. And if you have not done so already, please pause the video at this point and indicate what is this small change in the radius and height due to the thickness. Okay, so going back to this picture we have, which is very telling, the thickness is associated to the can itself. So if we look at the radius, that thickness really only corresponds to one side of it. So the dr, the small change in radius due to that thickness, would simply be 0.04. However, if we focus in on the height, the thickness is affected on both ends. The thickness associated to the top and the thickness associated with the bottom. That is to say, dH, instead of being 0.04, would be 0.04 plus 0.04, so a total of 0.08. And this, I believe, is the biggest difficulty associated with the problem. And we have now translated this into a much more, I'll say, reasonable computational problem. Determine this quantity that we have indicated. So our first step is to determine what is dV. So recall dV in general is going to be given by V sub r dr plus V sub h, these partial derivatives, dH. And going back to our above formula for V, we can note V sub r, the partial derivative with respect to r, is 2 pi r h. V sub h, the partial derivative with respect to h, is simply pi r squared. So the desired quantity, dV, when r is 4, h is 12, dr is 0.04, and dh is 0.08, ends up being, so v sub r would be 2 pi r times h multiplied by dr, 0.04, plus v sub r of 412. So r is 4, and there are no h's to worry about. And dh is 0.08. So we've simply substituted in the proper formulas and values. And if we were to plug this all into a calculator, we would end up with 16.08, and the units associated would be cubic centimeters. And you don't have to think too much about the units, but if you want to kind of track them a bit, note in the first portion of our formula, the 4 has centimeters, the 12 has centimeters, the 0.04 has centimeters. So we really do have cubic centimeters. And just to finish, our answer would be that the true change in volume is approximately 16.08 cubic centimeters. You will investigate a similar type of example as part of one of our homework assignments. And that completes our topic of tangent planes and approximation, so stay tuned and take care.